So welcome again. And we have a specific topic today on welded steel mill stocks, which is very specific. In the Netherlands, we started the research last year because we had 2 instances of stock failure. And that was a reason why we wanted to know more of how this could happen. And we are going to share these conclusions with you, but moreover, we are going to take you into the process on how to organize a community-based safety management. So I think because not every mill in every country will have welded steel stocks, but I think the method we used could be useful in any country. So that's what we want to focus on. Let me see. I think I can give the word to Jippe, and you want to controls as well?
Well,
yeah, maybe best. Huh? Maybe best. So we go to the PowerPoint. There you go. So check links. Yeah.
Yes, there we go. All right. No, Susan is listening. So welcome everybody. So as Nicole already said, we're going to be talking about steel stocks. And for us, that was quite a new word because we, of course, in Dutch, we talk about hoeden. And we, but for everybody, yeah, to have everybody on the same page, I'd like to start with a short introduction to steel stocks. Afterwards, I'm going to talk a little bit about the research project that we conducted here at the Hollandse Molen. Of course, the research project resulted in a tool which we have named the Roerie. I'll tell you all about it later. And lastly, I'll be talking a bit about the broader application of our method, and we think it can be very useful to, for other people in other countries, or to adapt our method to conduct more, make a safety management system on any part of your mill. So that's very interesting. So I'm going to start with the introduction. And in 2021, we had 2 instances of stock failure. So quite unexpectedly, actually, at 2 mills, the steel stocks, which are of course the steel, welded steel, large beams that form the windmill sails. Quite unexpectedly, at 2 mills they broke. Fortunately, there was only material damage, so no personal accidents occurred. But these accidents, they show that there's some kind of urgency, of course, because we want to increase the safety at the mills. And the governmental guidelines to fabricate these steel stocks have been retracted only a couple of years ago. And that has now resulted in that there's no universal safety management system in place that kind of oversees the manufacture, the inspections, and also the operation of these windmill sails. For us, this was a reason to look into it, into these steel stocks. Well, we keep talking about of course, the welded steel stocks, and I'm going to briefly talk you through the history of the Dutch windmill sails, because it might be a little bit different in every country. But in the Netherlands, of course, the oldest type of windmill sails were made from wood, and these wooden stocks, back in the 19th century, there's written evidence that they would last only about 9 years, and then they would break off, and then they would make new ones. Of course, this was quite expensive, so halfway through the 19th century, when also steel ships started to be made, there were some shipwrights who used the riveting techniques, and they also made riveted steel stocks, which was a quite revolutionary invention. And of course, from about the early 50s of the 20th century, welding became more common to a construction method, and then these stocks were welded. Well, in 1985, there was a governmental guideline that was proposed detailing how to fabricate these stocks, and there was a engineering company who was hired to do some calculations, and they really there was a very good base for yeah, how to fabricate the stocks and to what the criteria that they have to meet. In 2011, there was a second guideline, and that was retracted in 2013 after we had an episode where with the stocks in two parts, and people who've been in the mill world might remember this from a couple of years ago, but there was an idea to make the stocks into two parts, and then it would be joined together in the wind shaft. But this ultimately wasn't a good idea. So then the government retracted all the guidelines for the steel stock. Since then, there has been no real overseeing guideline for both the health and safety aspect, but also the fabrication. Our focus for today will be welded steel stocks. So we won't be talking about wooden stocks or the riveted stocks. This morning we had an interesting conversation with some of our Belgian colleagues, and they told us that they also have steel stocks, but theirs are mostly riveted. So this is also why we wanted to organize this conference in a more international context, to also hear about stocks in other countries. Well, and the interesting part of our research is that we really had a bottom-up approach. So we didn't want to impose more rules and regulations from the top, but we want to, as the mill community, well, we have a really community-based approach to make these rules and regulations because it concerns us all, the safety of our mills. Our research project essentially has three parts. And the first part, we started with an analysis of all the stock failures since the year 2000. And the year 2000 is significant in the Netherlands because the last 20 years has been characterized by the maintenance of the mills is much better than before. And there's also, since about 2000, because there is a subsidy system that requires you to inspect the mill quite regularly. So, and we found that since the year 2000, when there's regular inspections and regular maintenance, the breakages or the failures, they haven't declined. So there is something going on there that makes us think that these failures are not caused by the maintenance state alone. So this is good to know. The second part is that we'll be we conducted lots of interviews and really got all the stakeholders involved together to essentially form an overview of the current practice in the Netherlands surrounding this. So it's both the manufacturing, the design, the inspection, and also the operation. So the millers themselves are also involved. So we had to make an overview of the current practice. These two analysis parts were then formed into a sort of conclusion where we give advice and recommendations for both assessing these older stocks that are still present in Dutch mills, what is their remaining lifespan, but also to see how can we organize the production of new stocks and can we put any regulations into in place. It was quite a broad subject, but we to give us a nice starting point, we took the life cycle of a steel stock, which is so it starts at the design and it ends when it's replaced. So then we have a full overview of all the aspects of its life cycle. As I told you, in the last 20 years there was no declining trend in the failures, so that really made us think there must be some more root causes than just maintenance. So there's something going on. The role of maintenance. And our results are, of course, not a tool for rejection or approval of older stock, but we only investigate what are the risks and how are these accidents, what's the cause of these accidents. So for us, it was very important to make this a community-based research project. And in order to do this, starting with the life cycle of these stocks, we identified all the different stakeholders that are involved in the production and etc. And we conducted a lot of in-depth interviews with more than 20 of these experts, both from inside and outside the mill world. And this is also how we came to meet Paul, who will be talking to us later, because he has conducted a similar research project, but then with the ship's spars, so masts and booms, etc. Also, we wrote lots of articles in the Dutch mill publications asking for input, and we had a lot of phone calls and emails. So we really were amazed by the amount of help that we got. So this really gave us the feeling that this is a very broadly supported project. So lots of useful help. Well, briefly, we're going through the results. Yeah, so here's an overview of the stock failures since 2000, 13 in total, of which 2 were involving riveted stocks. So those are, well, not outside the scope of our project. And for each of these, we identified what is the root cause of this failure. And also by talking to a lot of technical experts, we identified 3 root causes of failure that are very important to keep in mind. And it's important to keep in mind that these are the root causes. Of course, the failure itself is quite a complex situation where there are several causes are working together, but each of these failures can be boiled down to one root cause that really was the main problem in this stock. And well, these are either corrosion, problems with the welds, and metal fatigue. And the metal fatigue, I have to explain it a little bit more, because the metal fatigue is always, of course, when there's a bad weld, there's also metal fatigue can happen. But this type of metal fatigue is a defect in the design. So we identified, this is called a stress concentration. So there's, of course, the stresses through that run through the steel stock when it's turning, they have to be uninterrupted. And there are certain parts in the design that can interrupt the free flow of the stresses. And at these interruptions, well, there's a really high stress load, and that can cause more metal fatigue. So in general, we identified that there are several factors that can decrease the lifespan of a steel stock. And these are actually years of heavy use. The length is very important, and also the weight of the rigging. Of course, it's the contrary to what many people thought, and we also had a lot of discussion about this, that the force, the wind, is actually well, much smaller effect, but it's actually the constant turning around of the stock that is that causes the most stress on it. So we always use the analogy of a paper clip that you can bend all the time like this. So when it's turning around, first, of course, the weight is pulling it like this, and then it turns around, and then it goes like this again. So so imagine the paper clip again. If you do it a lot of times, then after a while it will break. Also, contrary to what you might think, is that the load on the stock increases when it's turning slowly. And this is because the centrifugal force, when it's turning quickly, will keep it together, but then only when the speed decreases, it will break. And of course, it's always a combination of these factors. In the period of these last 20 or 22 years, we found that almost 700 stocks were replaced, and well, only 13 were replaced after a failure. So this was also a nice statistic that made us think, well, there is, of course, we have these almost 700 that we have replaced in time, of course, but these 13 failures, there are still, it's, well, almost one a year, and this is still too much. So this we really want to tackle this problem. A big limiting factor in the increase the safety of these stocks or to increase the strength is the traditional design. So we have a photograph here of the mill on Texel, and as you can see, the stocks, they go through the wind shaft, and the hole where they go through, this is the limiting factor on how big you can make the stock. So yeah, usually when you want to make something stronger, you can make it bigger or heavier. But of course, when we're confronted with the limited size of the hole in the wind shaft, and this, of course, is the limiting factor on how heavy the stock can be. It's always a balance between weight and also because of course, if you increase the weight, it will make it stronger, but the weight is also then again causing more metal fatigue. So it's a very interesting balance. Also, by analyzing all these breakages, we have shown that these well-made stocks, they can reach an age of more than 50 years. So one of the main conclusions also is that we think that the stocks that are made today, they're of a much higher quality, and we're quite sure that they can last for more than 50 years. We also made an age diagram of the age of all the steel stocks. So I put in a red bar, and that's the so you see the age is like this, and the number of stocks is on the vertical axis. So 37 years ago, this is the introduction of the first governmental guidelines. So the part below the red bar, these are all the stocks that have been made without any governmental guideline. And our idea is that these, well, we really don't know how they were made. So at least the ones after 37 years ago, they were made under some sort of governmental guideline. So this really made us, this really visualizes the problem that we're going to have in the next maybe 5 to 10 years, to start to replace all these older stocks. We found that the knowledge in the field is not spread out evenly. So we found that by talking to all these experts, they are, and this is also because of the absence of any governmental guidelines, everybody is doing their own thing, and they also, all the stock makers, they all are very serious about it, and they all have their own designs, and they think very seriously about them. But they don't share any knowledge. So the current practice is of a high standard, but the information is not shared. The same is true for the inspections. So the inspections are not carried out uniformly. There are many types of inspection methods, and people, or the inspectors, there are several instances that can inspect stocks, and they all use different methods. And lastly, we also found that when you order a stock, there is no enclosed documents or instructions or any type of information on how it's made, how you should be operating it, how you should handle it. So, well, these are all, of course, our findings. So these were the findings in short, and then in our report, we present advice and recommendations for these different stakeholders. So we present the advice for millers, millwrights, inspectors, mill owners, and also for the Cultural Heritage Agency, the RCA. And these are all, well, you can all read about it in our report. And we also recently made an English summary.
You can find this on the website.
We will link to it at the end, I think. So some example advice, and these are some horror pictures that we also got from a mill somewhere in the Netherlands. We found that it's very important to do internal inspections. So this is also was the subject of our talk this morning with some inspection companies. So these two pictures are from inside a steel stock, and this is what you can see if you take out one of the part of the rigging and stick, for example, a small camera inside. So one of the big advices that we give is please do more internal inspection of these stocks, because this can give you a lot more information on the state that they are in. So that's the picture on the right, and the picture on the left is a incomplete weld. So these are all also, we identified these as really big problems, that many older stocks have these incomplete welds, and this is something that we should all look out for. More recommendations are that we, so these are the conclusions, that we monitor the stocks more regularly and more systematically. And we give in our report more advice on mill handling, inspection methods, but also the preservation of heritage values. So stocks that were made in the 1960s, for example, we don't want to throw them out or without thinking about it, but we also advise the Cultural Heritage Agency to think about a method how we can preserve also the values of these stocks that might not seem to us now very interesting, but in 100 years they will. We were very stupid by throwing them out. Well, further steps. What are we going to do now? So after our report was done, we wanted to make it into a more manageable tool for mill owners. So this is why we developed the risk assessment tool, the HURI. We are also going to talk about the development of new guidelines for inspections. So we want to have a universal guideline for how the stocks are going to be inspected, because everybody does it in a different way now. And also for new stocks, we want also to develop more guidelines for the manufacturing of new steel stocks, because the stock builders, they are well, very serious about it. They all make high quality stocks, but there needs to be some sort of golden standard, or at least that we are sure of the quality. Well, in short, what is this risk assessment tool? Because that's, I think, the most interesting part. This is a tool that can classify these steel stocks into different risk classes. The method follows from a risk assessment and evaluation system, which is a very common system to classify and it's from the safety world, so it's actually used to make workplaces safer and operating of machines to make it safer. We adapted this methodology to be applicable to a thing, so the steel stock. And it's very nice because this methodology can combine different types of risks into a mathematical formula. Okay. Well, and it combines it all, and these different types of risks, they all work onto each other, and then it produces this risk class. The score is based on 3 factors, so we thought we both consider the usage history, so has there been heavy weather, has it seen lots of turning, lots of cycles, technical details, so I talked briefly about these design flaws that can increase the stress concentrations, and also the surroundings. So a mill that is in the city with lots of traffic around it forms a higher risk than a mill that is somewhere in a field. So it's almost 40 questions that you can fill in about your steel stocks, and then out comes the risk class. The questions that you fill in, they also, if there is certain, if it identifies certain dangerous or more riskful aspects on your mill or on your stocks, this will also make a little tailor-made advice with which you can work further. Well, each risk class, it's like a traffic light, so it's all in Dutch, so I won't bore you with it. What we've done, we're quite proud of it, because we think these have a very broad application in the safety management. Our research has shown, at least the report has shown, that involving the whole community ensures broad support. So it really feels like we have the broad support of the whole mill community. And our next step is now to either to draft up more rules and regulations, but we're going to do this from the bottom up. So, and we found that in a field where the governmental guidelines sometimes might be difficult to apply to your old mill, for example, it's a very good idea to well, as a field, to unite and then to make the rules yourself. Well, this will result in a much safer practice and rules that are much more tailor-made to your specific mill or well. And we think that this method can be applied to many more mill parts and different types of mills. Yeah, so we're quite happy that we can involve the whole community. And also by making this risk assessment system, the HURI, we also give the people on the mill themselves, we give them more tools to identify the risks, and so that they're not dependent on these inspectors or the millwrights, but they also, it's a campaign to also make them more aware of all the kind of risks. So, well, I think this is
this is it.
Yes,
we have now some time for questions, and I saw already one question in the chat. I will try to look it up. Ian Wilson's asked, have you considered the aerodynamic blockage effect of the tower on the stock and the windshaft loading? This will have a cyclic effect and will affect loading and therefore fatigue, which is correct, I think.
Yeah.
But,
this is true, and this is interesting because I'm currently also researching the book, The Dutch Windmills, that you might know, it's the Prinsenmolen book. And this is a research from the 1940s where they also already discovered this. And of course, this is the reason that the modern electrical wind turbines, that they have such a small tower.
Yeah.
This does have a cyclic effect, and there are many more of these loadings. There's also a torsion part of it. So these are all parts that are the stresses that all go through the stocks. So yeah, we have discovered it. We have considered it.
If you have a question, you can unmute yourself and just ask the question because the group is not so big. So if you want to do that, that's okay. Raise your hand and unmute yourself. Yes, Bill, please. Bill Starling.
I wondered, have you thought about trying to put any sort of preservative inside the stock? I mean, just simply oil, for example. And if it was oil, it would actually spread itself around very nicely while the mill was turning. And also, were all the failed stocks made from the same thickness of steel? I wonder whether that had any bearing.
Well, I'll start with the last question. So the thickness of the steel, so these governmental guidelines from the 80s, they prescribe per also the length of the stocks and also the type of rigging. They prescribe how you can make it with the different plates. So the thickness of the plate, and of course the thickness decreases when you get to the end, because you want the most strength in the middle, but then the tops will need to be light. So this is something that is, and of course these guidelines are retracted. So this is something that we have to find some form to get it back again. And your first question about the preservation on the inside, today it's done. There's wax products that are sprayed in. But many of these older stocks, they don't. So the horror pictures that I showed you from the inside, these weren't coated with anything. And also the last couple of years, there's also been stocks that are made from Corten steel. So this is a type of steel that is also better resistant to corrosion. And the oldest stocks now in the Netherlands made from this type of steel are from 1991. So we're also hopeful that this is also a...
Okay, thank you.
Conclusion.
And adding to the first answer of your second question, that's exactly why we want to have some enclosed documents or instructions if new stocks are delivered at your mill. So then you know what the thickness, for example, of the steel was when you got them. And if you measure it after 10 years, then you know if it has, I won't say increased, but decreased. Increase it will not. So then you have much more to go on. And then you have your own, how do you call it, stock passport or something. So you can follow it. And in some kind of dossier. And in this dossier, you can also put if something happened during the life cycle of your stock. For example, if it got into a storm or it was hit by something, then you can put it in your dossier, and then you know at what moment something has happened. So you can much more follow the quality of your stock. I also see some comments of Alan Gifford, who says initial design is a key factor. That's I think what Jip already said, that which you have to regulate in the guidelines. And I know that a lot of stock builders are using their own design. So the quality is okay, but it would be good if it's also put on paper so that everybody can do it the same way and have this dossier on your stock. Then I have from James a question. Have you considered the connection of the tips of the stocks together with a steel rope, which would prevent the reversal of stress due to rotation?
Well, that's an interesting thought.
Yeah.
I don't think we really considered this by using the steel rope when the mill is turning, but this practice is done when, especially mills that are situated in a location when it's difficult to get a large crane, for example, there. Then it's a practice to connect the tips up as a sort of rigging to hoist up materials or tools. So that is used in that context, but we haven't, no.
But thank you for this this suggestion.
Thought,
Interesting thing. So as we already told, we have now done this research and are presenting it, but this will be an ongoing research, I must say. So it will not be finished for a long time, I think. Any other questions at this time? Yeah. Then I think it would be a great idea to give the floor to Paul van Omme. And Paul, let us find you so we can make you host. I think you can point on the, shall I? Oh yeah, you can, yeah. So you can share your own presentation with us, and thank you for doing this.
Right, so can everybody hear me?
We can hear you.
Good. Yes. Okay, good. Before I start the presentation, which is a PowerPoint, I must tell you that, or maybe warn you that what I'm going to tell you is purely from a Dutch perspective. So, and what you have to know is about us Dutch is that we arrogant bastards, we know best. And particularly if you're a captain on the ship, I mean, there's not even God can well, anyway. So that's, when it comes to rules and regulations and how to behave, there's nobody who knows better than you as a captain. And the smaller the boat becomes, the more you know, the better you know, probably. So I don't know whether this is a universal thing, but small entrepreneurs, they hate rules and regulations, and governmental officials are idiots there to make your life really difficult for you. And nothing that do have any perspective, any bearing on safety or whatever. So that's, I think that's the sort of background you need to know before I go further. Let me try to share my screen. This is the one. Share. There you go. Can you see this? I don't know whether you can see this. I can't see it. Can you all see this?
Yes, perfect. You can put it on.
Let me just put it on start.
F5, yeah, F5.
F5. Yeah.
Here on.
There we go. Good, right. So I'm going to talk about industry standard for spas. In Holland, we've got loads of traditional ships, sailing vessels, as you can see down here, but just a couple of examples of them. We've got about 50 seagoing ships, traditional ships, and 300-400 inland water barges, and all propelled by sails. So as you can see, the masts will carry the sails and carry all the load, so that propels the ship. The ship here on the nearest to the camera is the Morgenster, a brick two-masted brig. It has mast, it has an impressive bowsprit, and I understand the captain just replaced the bowsprit by even a bigger one. So there's all sorts of psychological analysis that you can make from that. But I thought it was impressive already as it is. And then on the background, you've got the typical inland water barges. Most of the times one-masted, sometimes two-masted ships. So there are a lot of spars on these boats, and the thing is to make enough headway using the wind, and not going anywhere else. This is a ship down here, which is called a scootje, I think it is, and typical Dutch thing. It's not professionally operated. It's not with paying passengers, and that's another basic thing, important thing you need to know is that we earn the money for the upkeep by sailing with paying passengers, right? This boat here is this is probably taken during a match. These 100-year-old barges are driven to the absolute border of what is possible and beyond. There's one funny little detail. If you zoom in, look in exactly in the middle, there's this guy somewhere in between the mast and the boom and crawling from underneath the sail. It's a funny position to be in. But anyway, in the old days, when there was a wind gust and an overload of power, the sails would probably have blown out because they were made of cotton or something else. But with modern materials, these things don't give way. So either the mast breaks or the boat capsizes, and like happened down here on this boat here, it capsized. But this is a race boat, a 1-year-old race boat, and it just pushed it a little bit too far. Another possibility is that the mast breaks. The angle taken here is from which a photo was taken is it's from the back, but you can see the boom part of the sail on the right-hand side or the starboard side, and part on the port side on the left side of the sail, and the foremast broke. The thing is, if you have these wooden mast or steel mast, even, it doesn't really matter. The problem is that if you have a look at a mast, the only thing you can go for is the outside. So you can judge it from the outside, but the problem always starts from the inside somewhere, rotting process or what have you. So damages. So, and it's really difficult to judge. You need knowledge to judge this, and experience probably. And the rules don't help you. The rules for inland water barges are harmonized in Europe. So that's what we've got to deal with, but they don't help you a lot. It seems a bit like the story Jippe just told us, that it's more about the dimensions. If you have a mast this tall, then it must be of a diameter of so and so much. So nothing much to go by, only when you build a mast probably, or place a mast on your boat for the first time, but nothing much to judge on while operating your ship. So there's rules, but it doesn't help you a lot. So let's go back to this ship here. This ship broke its mast at a very unfortunate day in 2016. On the top photo, you can see the boat approaching the port of Harlingen. And the jibs, the foresails were already lowered. There's a couple of people on the foredeck trying to lower the mainsail. And on the picture below, you can see that the sail is on the deck, but also 6 meters of mast. The top bit broke off, and it fell on 3 passengers, 3 German tourist passengers on board the ship. They died almost instantly. I think from the stories I heard, they died instantly under the extreme weight of the mast. And there wasn't a lot of wind, so there wasn't a question of an overload of power, something that the ship should be able to take easily. So an investigation was started. This was done by the safety board, amongst others. There's all sorts of governmental authorities and bodies that start investigations, like criminal investigations, but also like, did you comply with the rules and that sort of thing. And the safety board started an investigation with the aim of trying to find out if there were any lessons to be learned, if we could learn from this. Not so much to blame somebody, but to find out what we can learn from this. So they zoomed in on the problem. And what was the technical bit is that it's encircled down here. You can see that on the top bit of this foremast, there's a gaff. It's a fork-shaped sort of thing. And to protect the mast, the wooden mast from shave, an iron piece of metal sheeting was attached to the mast. And that is, the owner is responsible, that's clear. And they removed the iron sheeting, as you can see on this picture here. This is one of the inspectors. As you can see, the wood is completely gone. It's pulp. It's like there's no splinters or something. It's just a pulpy mass. And so they reckon that 75% of the original strength was gone and only 25% was left. So it was just by the sheer weight of the mast that could have brought the whole top down. And it took a little bit of wind in this case, but it could have just fallen off almost spontaneously. So that was how bad the situation was. And the thing is, in the beginning, we organized meetings with captains, skippers, operators of these boats, and they said that the inspection bodies were to blame because this ship was issued a safety certificate, a rigging certificate in particular, just a couple of weeks prior to the incident. So an inspector came on board, did his survey or her survey, found nothing wrong with the boat, issued a certificate, and went home again. And as I showed you before with the rules, there's nothing much to go by on when it comes to the rules, right? So if you're an inspector or a captain, you must know that this metal sheeting may hold some dangers, or that there's particular places where you have to look for. So what we first learned, and that's why this piece, this slide was here. We first had to explain, or that was legal people that they said the owner in the end is responsible, not the inspector, not somebody who issues a certificate. It's you who is responsible for everything in the end. If you organize an event and you invite people of the general public to attend the event, then you as an entrepreneur or organizer must be aware of all the risks that are involved in this event. You must take every action that may reasonably demand it from you to mitigate these actions and keep it at an acceptable level. And the law doesn't help you here. The law doesn't tell you how to do this. It just, this responsibility lies heavily on skippers in particular, but everybody who organizes some sort of an event. Right. So what the safety board did is they wanted to know what the level of knowledge was amongst ship operators, a bit like what Jeppe also told. So, like, they set out a questionnaire among ship operators. They got 150 respondees, and the funny thing was that there appeared to be 150 different ideas about what proper maintenance is for spas, and there was no common idea on how often you as a ship operator should inspect your own rigging. So there was answers varied from, when it comes to these inspections, varied from once every month. Somebody will be sent up the mast and the rigging and do inspections, and to once every 4 years or every 5 years, just to prepare for the official inspector to pass by to make sure that no surprises will come up. So somewhere in between a month and somewhere in between 4 or 5 years. And about maintenance, all sorts of different materials were advised or were ill advised. So there's all sorts of differences. So what the authority said, the safety board, when they come up with their recommendations, they said, we are not the experts. The government is not an expert. And this very much sounds like what's happening, or it's probably a familiar thing for you people operating windmills, right? So it's a niche sort of thing to do. Only enthusiasts know about it, but what they said is, we don't know, but you as an operator are supposed to know. And it seems to us that there's no common ideas about how to treat these spas properly. So what you have to do is, you'll have to come up with some sort of a standard. You'll have to invite all operators, and not all operators, they were specific, the most responsible and experienced operators, because they found out that some of these advices that they got back from or answers they got back from the questionnaire very much were in line with what the analysis from some technical institute found. So invite all your best operators, invite all the inspectors and experts who build masts and do maintenance on masts, put them all around the table, lock the door, and don't leave before you filtered out all the BS about how to maintain these masts, to agree on what is actually needed and set a minimum standard. So that's what we started. That's where we started with. We started to set up an industry standard. But another problem is, and just tell me, Jeppe, if I run out of time, just interrupt me. Yeah, right, good. Okay, so the problem is that, as I told you, being Dutch, and being small entrepreneurs or a small businessman, we hate rules. And we like to criticize them. But we found ourselves in a very difficult spot when the safety board just more or less ordered us to come up with our own rules. So at the beginning, we felt extremely uncomfortable with that, because what actually is the meaning of rules that we have written ourselves? And the fact is that once you've written down rules as an industry, and you call it an industry standard, as we've done, then it becomes really difficult for a ship operator to do something completely different. If then an accident occurs and an investigation is started, and it turns out that you've inspected, for example, your rigging only once a year, where we have recommended to do it at least twice a year, then it'll be really, you must come up with a really good story to defend yourself. So an industry standard may not be not a lawful sort of thing. It's extra, how do you call that? It's something that goes above the law, but has the same sort of effect in the end. But anyway, we had to start with it. So that's what we did. We focused on the people on board working on deck. So it's not for inspectors, it's not for lawmakers, it's for us people working on these boats. So we found sort of formats on that on the internet. There's all sorts of industry standards approaches. There's nothing unique about what we've done. We set out to come up with something really simple, because our skippers, they hate letters. The more letters they'll see, the more, well, they get agitated and anxiety problems. So we try to minimize the number of letters that we use and try to squeeze it into small little pages. So this is basically the contents of our industry standard. The first thing that we did was to identify the critical regions of all spars. So these things tend to start rotting almost always at the same places, right? Because where stress loads are biggest, where water can seep in, for example, that sort of thing. So that was the easy bit. So we identified all critical regions. Then at number 2, we discussed on how often you should check, at what moments in time you should check your spars and riggings. And we agreed upon that. So that's with a certain set of certain interval and after certain incidents where stress loads occurred. Then we discussed, that's number 3, how to control your rigging, how to control your spars. What sort of tools you can use for that. And then the next little bit, and that's an important one, of course, is how to assess it. So what are the critical sort of things you have to look for? How do you identify rot? How do you recognize rot, for example? And what are the telltales or the red flags you have to look out for? And then what came, the bit where we discussed the reporting. Reporting becomes extremely important if you do like frequent checks, because you'll have to monitor or map the progress of a rotting process or your spars. Then we discussed, sorry, that was one back, I think, so one back. Then we discussed maintenance. What sort of materials to use? For example, one of the things we came up with was that if you paint a mast, a wooden mast, and you use like a bright colored varnish or transparent sort of varnish, you can easily see the places where wood starts rotting. If you use dark sort of paints, then it may protect masts as good as transparent varnishes, for example, varnish paints, but you can't see where the rotting processes start. That's one of the things we came up with. And then we developed some sort of a checklist that makes it easy for people on board to work with. Just zoom in on just 2 or 3 things of this industry standard. So one of the things is that once you do an assessment of your rigging, and you'll have to remember that you have to write everything down, you have to report things. That we came up with a standardized sort of reporting. So something is either good, reasonable, or bad. So once something is good, then no action is needed. When something is reasonable, then of course you have to take preservative actions, but you may plan it in and don't necessarily have to stop business immediately. And when something is bad, it means that you have to invite somebody with proper knowledge, an expert, and see what the expert makes of it. So this is how you report. We come up with, standardize that. And then another thing is, maybe if you remember the little picture I showed you from the wooden mast with these cracks in it, that was a third or fourth slide. There were big cracks in the wood. And the thing is, that was one of the things we came up with during the questionnaire that was interpreted by people completely different, dependent from one person to the other. And we came up with some sort of set of rules that if the crack is about this wide, then you'll have to invite somebody else. And if it's that long, then you'll have to invite an expert and let the expert make a more holistical sort of assessment of the mast. So it actually gave operators on board some tools to assess the mast. So one more, no, that was it. That's it. So maybe just one more little thing before I stop, and that's once we've written all this down we did it ourselves, right? Ship operators. And once we started handing out the industry standard to ship operators, the resistance started. And so I still feel that we haven't accomplished what we set out to do. The idea that this is something that we have done ourselves, that it's our rules, it's our expertise that we've written down, because there's one thing that's one sort of hurdle that we can't take, and therefore you probably need a psychoanalyst or a therapist. That once you've written something down, it appears to be rules, and we haven't solved the problem of skippers don't liking rules, you know. So that's still an enormous sort of problem. That's it.
Thank you, Paul. Thank you very much for this insight in the shipping context. How do you call that? Maybe there are some questions from the participants. Look, somebody has some questions. Oh, you've been very clear, I think.
Well, there's maybe a difference. I find that's why I mentioned the fact that the people on our ships, they run them professionally, right? So I find it that even in with yachting, pleasure yachting, that the people running those boats often are extremely professional about and methodical about the yachting business. And it may be that volunteers just have in often cases don't mind too much about protocols and a methodical sort of approach. Whereas as an entrepreneur, you're much more, particularly if you're a small one, you feel like you're hampered in your entrepreneurship by the government and by the rules. Whereas you as a volunteer, you probably don't have the same sort of problem. That may be an important difference here.
Okay. I thought it was very interesting because it shows something on, because we did research on steel stocks, but maybe you can translate this to wooden stocks, because it's the way, how you can look at it. The problems you have with ships, well, maybe some points are the same as we have with mills. Yeah.
Yeah, if I can reply to that, yes. The industry standard was for both wood and steel masts. And I think the essence of it is that the idea that you are responsible for the safety on board and for everybody on board. And if something goes wrong, that you are the one to blame. So you'll have to assess the safety situation, the risk situation all the time. And you need tools to do that properly. Like you'll have to agree upon a frequency, you'll have to agree on the reporting sort of system. So the system will help you, whether it's steel or wood. And it's actually, the responsibilities are the same. And the method you need to assess the risks is exactly the same.
And can you tell a bit more, because it was a community-based awareness process, I think. Can you give, how long did it take you? Can you say something about that?
It took us about a year, but we started really slowly, like because I told you that we felt a bit hesitant about doing this altogether. Although once the safety board comes up with a recommendation, it's not a voluntary thing at all. If you don't follow up on the recommendation, the minister by law has to, within 2 years' time, I think, assess the situation. And if he thinks the industry or the recommendations won't follow up properly, then the minister has to issue rules or take mitigating actions and come up with something else. So, but we started slowly, and then it took us about a year to come up with the industry standard before we could issue it to all ship operators. It's about a year. And we tried to involve everybody active in the field, but particularly invited the ones that we knew were very knowledgeable about wooden and steel masts to sit on the table. So, but we tried to keep all people active in the industry abreast of the developments. But we didn't get a lot of feedback, I must say. One little thing that but I thought it was an extremely inspiring process. But the ones that were actively involved, it was a super good discussions, and it was we learned actually a lot. And I think we took it really a level further. So it was a very good process.
I think we experienced the same thing. So going into this process is already a good thing to do, and which we can share with you. Are there any other questions? I prepared a small poll just to get some intel on if there are any steel stocks in your country. So that's just 3 questions. Let me see. Oh, here we are. Yeah. Launch. I think you have it in the screen. I think you can answer the first question. Is it correct? Do you see the questions? Yeah. Okay. Yeah, I'm not sure what you see. This is the first time I use the poll. So. Yeah. Let us see. Okay, bye-bye, Gabor. Okay, 7 people have answered the poll. Nine people. Okay, it gives us an overview on the situation abroad. If we see, do you have welded stocks in your country? I think, well, 9 out of 10, 90% says yes. So it's a thing you also use in your country. So the research we have done could be interesting for you, and especially the recommendations we did for the different stakeholders. Well, as we already said, the conclusions of the report, which is just one A4, are on our website. And if you want to know more, please contact us also on how to conduct such a survey and research. Stock failures also 80%, unfortunately. They break, and I would like to know a bit more about that if we go into the discussion, because did there happen any accidents, and how did you follow up on these failures? And then also very interesting, do you have a safety management procedure or a risk assessment tool? Well, also 80% says no, we do not have it, and that's an interesting thing, and that's the key reason why we thought this would be an interesting topic for this conference, because we hope we can learn from each other, and that's why we invited Paul, because we can also learn from other sectors beside mill sector, but still a lot of people, a lot of countries do not have this. So this is an interesting little poll. maybe somebody can say something about the stock failures in your country. Can you say something about the examples and about the reason why they failed? I don't know who answered this question with yes. Please come forward. You have to unmute yourself if you want to say something. Oh, nobody.
We had a stock failure, but it was back in 1976.
Oh, a long time ago.
And it was a wooden stock, not a steel stock in this case. And the mill had been in a state of disrepair for some time. And the local council had recently bought the mill, and they hadn't really put in a regular maintenance regime. But that's probably all I can really say about it. It was long before my time, so I don't know very much about it.
But there are still stocks in your country?
I believe so, yes.
Yeah, but there are no failures with those, as far as you know.
I don't know anything about that particularly.
Okay. Okay. Anyone else?
I believe there was a failure of a steel stock at Denver Tower Mill about 5 or 6 years ago.
Yeah. Do you do not know the reason of the failure?
No, I don't know anything about the reason or the follow-up. All I know is that the mill now doesn't have any stocks or sales.
Oh.
And do you have some central organization or person who makes an inventarization of all those failures or about the steel stocks in general?
I would expect the Society for the Protection of Ancient Buildings to have some knowledge of that.
Yeah, I think we will contact them because it's interesting for us to know also if there are no failures abroad, then it would be interesting for us. Maybe you do something right and we not. Could be, of course.
Nicole, maybe you can close the screen of the poll because I only see half of your face.
Sorry, I didn't know it was still open. 1 sec. Here. Oh, wait. End poll.
Can I speak, Owen Gifford?
No. These are the results. We will put this. Pause artist. And I will. Is it now gone, Hannah? No. Yes. Okay.
Yeah. Okay. Like this. Thanks.
Thank you. Thank you. Okay. Who was trying to say something?
I could say something. I have investigated broken stock, which was totally bad design with many design features that added to fatigue. And I believe that the design is the first thing you've got to get right, and ensure that the stress concentrations at any point are kept to a minimum by grinding or dressing the toes of the welds to ensure that you haven't got high stress concentrations.
That's exactly what also our view is, and that we really want to work towards a guideline that really implements all these ideas.
Yeah.
CS from James says, I don't have any examples of stock failures, but we have new steel stocks and have taken 3 precautions. 1, connecting tips of the stocks. We already talked about that. That's interesting. 2, we do not have any welded connection near the end pole. We use continuous steel member through the pole end. Okay. We galvanize after manufacture to prevent internal corrosion. Yeah, that galvanizing, we already tried to do that in Holland, but we only had a bath for I don't know how many meters to put in the stock.
Well, this was one of the reasons why these
divided stocks
into parts were developed, because they could fit into the bar.
But then you had a problem where because of the connection they didn't last, so we stopped that. So now we have to put one end in and then the other end in. So that's also not perfect. Yeah. So I don't know how large the stocks are, which fit in the bath, but we will maybe we see that in the chat because your microphone doesn't work. Yeah. And Manu says we have no examples of failures and the wood mast here. Yeah. Luckily, keep it that way. That's good. And try to inspect if it's going right, of course. Yeah. Okay. Any other questions or remarks?
Oh, I had to delay.
Okay. Oh, hey, sorry, you have. Oh, it was N and it was not a no. Please unmute yourself, Manu. Then you can say something about it. Excuse me.
Hi.
Hi.
Well, I have an old mill. I have two mills here on this place where I am, and one of the mills is really old. And one of the main reasons that was like abandoned, it was because of the failure of the mast, you know. But this was many years ago, maybe 40 years ago or something, or 30. I'm not really sure, but we have the example here, and it's still here. In a few time we're gonna dismantle because we have a new one to substitute that one.
Yeah.
Now we're gonna dismantle the old one.
Yeah. And you're from Portugal, aren't you, Manu?
Yes.
That's it.
I'm in Porto Santo Island. Even if I'm from the mainland, I'm here to rebuild this mill.
Okay.
And that's the thing.
Okay.
A stock failure also here.
Yeah. And do you have in Portugal an organization or person who makes an inventarization of the stocks and the failures? Is that?
I don't think so. My experience on industry also a little bit on metallurgical area and so on. I don't remember to have someone dedicated to this kind of work, you know, inspecting and so on. The laws here, I think, are really in the birth of laws, you know, on that matter.
Okay. Well, but still, thank you. Interesting. Yeah.
Okay.
Yeah. Okay. Any other persons would like to add something? Well, it is interesting if you have any information on this to send it to us. We really would love that. So please email me. You have my email, and I will make sure that Jippe will get it. And then we can also get this as a background or more information for the research we do and for the development of the further regulations maybe. That would be very interesting. So that's if you have that, please join us. Of course, we will put the presentation on the website of this network of the craft of the miller. If you would like to have the report, it is still in Dutch, but you can use Google Translate maybe if you want to have it. It's also online on our Dutch website, but I can email it to you as well if you would like to have it, or I can make a link. But, well, it is in Dutch, so maybe not very useful. That's why we have the conclusions, with thanks to Wouter Pfeiffer and John Cook, who made this little report on the conclusions. Well, if we don't have any more questions, well, maybe there are other questions which don't involve wood or steel or wooden stocks. Then we have some time for that. Okay. No more questions. Well, then I want to thank everybody for joining. This autumn we will have, I think, 1 or 2 other conferences. If you have any suggestions for topics, please contact us. That's also a good idea. And one of the topics for this autumn will be how to communicate the stories about your mill, which something very often attracts people because there's a lot to tell about the mills, about the history, about the people who were living there in old days, in new days, etc. And we have someone who is going to tell us something about that. And then we have, well, other topics also on the list, but we're still working on that. So thank you for joining. And I see some people sitting in the sun, which is great. It's sunny here as well. So I hope you have some good weather and we have a holiday weekend here in the Netherlands, maybe you too. So enjoy your weekend and lots of fun on the mill. Thank you for joining. Bye.